Problem number 6. All right, this one is a little bit confusing to look at. So I'll show you how I approach this one. It says angle HAM. The review is all the way down at the bottom, but it's the one with the staple in it. Angle HAM is a right angle. So I'm going to go find that. H down to A and then over to M. That is a right angle right there. And then it says that angle YMA is also a right angle. So from Y down to M and then over to A. That's a right angle right there. Then it tells me that HM, that's this piece right here, is congruent to YA. YA is right there. I'm going to mark them with some congruence markings here because it says they're congruent to each other. These triangles are laying on top of each other. That's really hard to look at when they're laying on top of each other. Are you guys okay if I redraw them as separate triangles so that it's easier to look at? So I've got one of them outlined in orange, the other one outlined in blue. So I'm going to redraw my orange and blue triangles. Thank you, Piani. All right, so this would be triangle HAM. We've got a right angle right here, and it's got a congruence marking on HM. Then we had our other triangle that I outlined in blue over there. Looks kind of like this. This is Y, and then M, and then A. There was a right angle down here, and it had a congruence marking right here. So far, so good? Those are just my sketches so that I can kind of try to keep my thinking straight and I don't get too confused by overlapping stuff. But I always have to remember that it's coming from this picture where they are overlapping each other. Yes. Yes. They do technically have a shared side there. What is the shared side? AM. So if I was doing a proof about this, I would absolutely mark that and use my reflexive property. 100%. All right. Using side, angle, side. If I wanted to use side, angle, side to show these two triangles are congruent to each other, well, it's already got an angle marked down here, right? So if I wanted to use side, angle, side, I need the sides on either side of that. That's saying the word side a lot. So I'd need these two sides, right? Because they're on either end of my angle there. So I would need HA to be congruent to what part on the blue triangle? YM. If I could get HA congruent to YM, and I shouldn't use just one mark on there, I should use two. That's got me most of the way to side, angle, side. Right now I have side, side, angle. Don't use that. Down on the bottom, AM, this side down here, would have to be congruent to what on the other triangle? AM. That's that shared side. And AM congruent to AM. Welcome, dear. You're going to need the test review. It's very bottom paper over there. There's 2 papers on the bottom. You want the one with the staple in it. If I had these pieces marked, ignoring this, that would give me side, angle, side, right? I just get an extra bonus right there. When I see it without that HM and YA is marked congruent. I see side angle side. But when I put those pieces back on, that looks like what? Side, side, side. So I need the same things here. I would need HA to be congruent to YM. And I would need my reflexive property, AM congruent to AM. All right. Take it back to just my given information here. If I was going to try to do hypotenuse leg, first of all, to use hypotenuse leg, you have to have what kind of triangles? You have to have right triangles. Things have to be perpendicular, right? Do I have right triangles? Then I could get hypotenuse leg out of this. To do hypotenuse leg, I have to have the hypotenuse and then one of the other legs. Where do you find the hypotenuse in a right triangle? The longest side. It's always directly across from what? The right angle. So directly across from my right angle. So this is my hypotenuse. On the blue triangle, this is my hypotenuse. Are the hypotenuses already marked as being congruent? Yep, that's part of my given information. So I need one of the other sides to be congruent to its corresponding part on the other triangle. So I could pick this side, because that's a leg on my triangle, right? Then I would need HA congruent to, what's the corresponding side on the other triangle? YM. So if I had that HA was congruent to YM, then I would have hypotenuse leg. Is that my only option? I could also go with what? AM. If I went for the bottom down here, that's the hypotenuse and a leg. And what does that correspond to on the other triangle? AM. That would give me hypotenuse leg right there. So far, so good? All right. One more. If we wanted to do side, angle, angle, or angle, angle, side, doesn't matter where my S goes, it just has to stay on the end. Do I already have a side that's being marked as congruent? Yes. Do I have an angle that I know is the same size as an angle on the other triangle? Yes, I've got those right angles, so they're congruent. Is my right angle touching my side? Here's my side that's marked as congruent. Is that right angle this one over here? Is it this one over here? Because those are the ends of this side. HM goes from here to here. So here's, I have to have one of those if I'm going to use angle, angle, side. Does it matter which one? No, I just need one of them. So what about if I went with this one first? That's at the end of this line segment, HM. Can I call that angle H? Is that okay, or do I have to give it a three-letter name? It's okay, because when I look at the picture where they're put together, see how H is all by himself over there? There's only one angle there. So I'd be okay to call it angle H. Angle H needs to be congruent to, what's the corresponding piece on the other triangle? Angle Y. So if angle H is congruent to angle Y, then I can show that these two triangles are congruent to each other by side angle angle, because that would give me, oops, that would give me this angle. So I'd have side angle angle. could I instead have this angle down here so that I had side, angle, angle? That's fair. Can I call this angle down here angle M? No, look at my original picture, because I only drew them apart so that I could see them better. If I look over here, there's too much going on there. I've got a blue angle M, I have an orange angle M, I got a weird thing that's like orange and blue. I'm gonna have to give this one a 3-letter name so that everybody knows exactly which angle I mean. M has to be in the center, because that's where I want to put my angle marking. So what could I call that angle? HMA. Angle HMA. Would need to be congruent to, look at the blue triangle. That should correspond to what? I'm sorry, one more time. YMA would be this guy right here. I want the corresponding angle for this one. So that's this guy on my orange triangle. What does that correspond to on the blue triangle? YAM, this one over here. Angle YAM. All right, that's a whole lot going on in that picture. What two triangles are congruent? When I write this, I have to make sure that I'm matching up my corresponding congruent parts. Triangle HAM, let me get that far. Triangle HAM and YMA. Absolutely. We know that H and Y are corresponding. They're both on the top here like little pieces of a crown. A on the orange triangle is a right angle. M on the blue triangle is a right angle. So those have to match up with each other. Because this is a right angle. And this is a right angle. On the orange and blue triangles respectively. And then M and A, that would be the little pieces of each of their triangles. What else would you guys like to see? Yes. Number 8? Absolutely. Number 8, we are going to complete this proof. First thing I notice about this proof is that there's 2 lines on the reason side that both say given. Go and look at the given information that we have. Do we have 1 or 2 pieces of given information? 2, they're separated with a comma. So I'm going to take this piece of given information, I'm going to put it on one of my lines. I'm going to put it on top just because. I could put it on the second line down, it doesn't matter. AC bisects angle BCD. And then I'm going to take this right here, and I'm going to put it on the other line for my given. BC is congruent to DC. Is that already marked up on my triangle for me? No, so I'm going to go and add it. BC is congruent to DC. Anything I'm allowed to mark for free, even though I wasn't told? Yes, AC, that bisector. AC is congruent to itself. My reason? Reflexive property. Did they tell me about parallel lines? Was I given something about parallel lines? Not this time, so no letter Z. Z is only for parallel lines. It says that AC bisects. What do bisectors do? Cut stuff in half. What is AC bisecting? What is it cutting in half? Angle BCD. Let's go find angle BCD. So we are bisecting an angle. BCD. Where should I be looking on here for BCD? My eyes should be drawn to which letter? C. I should be looking right over here. BCD. There's that angle. And the orange thing is cutting it in half. If I take a candy bar and I cut it in half, I get 2 smaller candy bars, right? If I take a pencil and I cut it in half, I get 2 smaller pencils. If I take a line segment and I cut it in half, I get 2 smaller line segments. What did we say we were bisecting? What are we cutting in half here? An angle. So if I cut an angle in half, I get 2 smaller angles. What are those 2 smaller angles that would be the same size? So ABC would have this as the vertex. So remember that center letter, BCA, that keeps me looking right here. BCA, that would be this little guy right here. And DCA, angle BCA is congruent to angle DCA. This little guy over here. Aren't they cute little baby angles? How did we know that we were going to end up with 2 same-sized angles? Because it said what? It says bisect. And what are we bisecting again? We cut an angle in half, right? We bisected an angle. So what are we using to say that these 2 little angles are the same size as each other? Definition of angle bisector. Do I have enough information to say that these 2 triangles are congruent to each other? Using what? Side angle side. Take my triangle congruence statement right here. I'm going to recopy it down here. Triangle ABC is congruent to triangle ADC. When I see side angle side, it always reminds me of a puppet mouth, because I have 2 marked sides there, and then the angle back there, like that would be the mouth part, right? Like back where their throat would start. That's what side angle side looks like. What else are we doing? Yes. 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 Number 7. Absolutely. Ooh, I love this one. An acute triangle. How many angles does a triangle have? 3. 3 angles, 3 sides, right? Of those 3 angles, if I have an acute triangle, how many have to be acute? All 3 of them. If it's an acute triangle, every single angle has to be less than 90. Well, if all 3 of my angles are acute, how many obtuse angles would I have then? 0. Because I only have 3 angles in a triangle, and I said all 3 of them have to be less than 90, so I've got none left over that could be obtuse. How many would be right? 0. I used them all up already. In an obtuse triangle, what does an obtuse triangle have to have? An obtuse angle. How many obtuse angles can it have? Just 1. Here's why. Obtuse means what? Bigger than 90. Okay, so I'm going to pick a really small number, but it's still bigger than 90, right? So like 91. If I have 2 angles that are both 91, and then I'm supposed to have a 3rd angle in this triangle, right? Well, if I just add these 2 together, That's 182. What does a triangle have to add up to total? 180. If I have more than one obtuse angle, it's going to add up to more than 180, so it's not going to make a triangle. So if I'm only allowed to have one obtuse angle, how many angles would have to be acute? 2. So how many right angles would we have in an obtuse triangle? 0. A right triangle. What does a right triangle have to have? A right angle. Otherwise, we wouldn't call it a right triangle, right? Am I right or am I right? How many right angles will our right triangle have? 1. Will it have any obtuse angles in it? Nope. So how many would have to be acute then? 2. If it's an acute triangle, all 3 angles have to be acute because every triangle has at least 2 acute angles. Have to have 2 acute angles, and then it's just that third angle. If the third angle is also acute, we call it an acute triangle. If the third angle is obtuse, we call it an obtuse triangle. And if that third angle is right, then we call it a right triangle. Yes? Number 11? Yeah. So there's 2 things I notice when I first look at this problem right here. One of the things that I notice is that they've given me information about all 3 of the sides. And all of those have x's in it. But I don't know if any of these sides are the same size. And I don't have any rules about what the sides of a triangle have to add up to. So I can't really do much with that right now. The other thing I notice is it also talks to me about angles. And I like it when it tells me about angles, because I do have rules about what angles have to add up to be. All 3 angles in a triangle have to add up to how much? 180. So I know this angle down here, plus this angle up here, plus this one down here have to add up to 180. Could I figure out how much that empty one is? I could use my linear pair theorem. But I also see this guy out here. What do we call angles that are outside of triangles? Exterior. I can use linear pair theorem and triangle sum theorem to solve this, but I'm going to practice using our exterior angle theorem. We learned the exterior angle theorem at the same time that we learned our triangle sum theorem. The exterior angle theorem says that my exterior angle, so this 108 degrees, is equal to the sum of my 2 remote interior angles. So these 2 guys over here. So y and 54. As soon as she gets back. What do I need to do to figure out how big y is? Subtract 54 from both sides. That makes it cancel out over there on the right. What is 108 minus 54? It's 108 minus 54. 54. So y is 54. Anytime I find out information about my triangle, I add it to my picture. So I'm going to come up here and put 54. That's how big y is. I'm still supposed to find x. Is x in any of my angles? It's only in the sides. Yes. Yep. So we can do 180 minus, and then I've got 54 plus 54. So that'd be 180 minus 108. What would that give me? 72. So this guy over here is 72 degrees. I'm going to change all of that to a different color. I still need to find x. Stuck. What's your thought? What kind of triangle are we looking at, guys? This is an isosceles triangle. How do we know it's isosceles? Two of my angles are the same. I've got a 54 up here, and I have another 54 down here, right? So these two angles are congruent to each other. If I have two angles that are congruent to each other, what's that mean about my sides? I have two sides that are the same size as each other. And then I've got one side that's not because this one angle is odd man out. He doesn't match the other two. How do I figure out which sides have to be the sides that are the same size? Because not all three of them are the same size. The ones that are across from my angles. So if I look at that top angle, the one that has the 54 printed in it, if I go across my triangle, that's this side down here that has the 7x minus 14 in it. What's the other side that would have to be congruent to that? 2x plus 16, that one over there. The 4x plus 9 is not the same size as the other two. What can I do with things that are the same size? Set them equal to each other. If they're the same size, we're going to set them equal to each other. So I'm going to take 7x minus 14, and I'm going to set it equal to 2x plus 16. Are my x's on the same side? First thing I have to do is get them on the same side. So I'm going to subtract 2x from both sides. So 7x minus 2x gives me 5x, and then minus 14 equals 16. What next? Add 14 to both sides. So that's 5x equals 30. Divide both sides by 5, and x is 6. We have 4 minutes until the bell rings. That's enough time to answer a short question if we've got a short one. You said number 4? Let's go look at number 4. Number 4. We are supposed to find the measurement of angle BDC. Well, here's D. Which angle is BDC? Inside or outside of my triangle? Outside. So we want this one. What do we call angles that are outside the triangle? Exterior angles. And my exterior angle theorem tells me that that exterior angle is equal to what? The sum of my remote interior angles. And here's my two remote interior angles. So 42 plus 37. What is 42 plus 37? 79. So angle BDC is 79 degrees. Well, if I know that is 79, how can I figure out this guy? Subtract it from 180, or I can do my triangle sum theorem. Either way, I can do 180 minus 79, which would give me what? 101. Or we could say the measurement of angle BDA plus 42 degrees plus 37 degrees equals 180. But notice what happens. When I combine these two like terms together, I get what? 79. Measurement of angle BDA plus 79 equals 180. And then just like when I did it using linear pair theorem, I'm going to subtract 79 from both sides. And I get 101. All right. Tomorrow is your test. Please turn in your warm-up paper today because we don't have any more warm-ups for the rest of the week. So go ahead and turn those into the basket for me. The answer key for this test review is already posted in Canvas. Who knows how to get there? How do I get to it? Go to the home page and then click on modules. You want to get to modules somehow, so you can go to today's lesson or you can click straight on modules. Scroll down until you see today's date. You won't see it right there in the module. You have to click on the page and then go to the bottom of the page. I am posting videos from all 5 of my geometry classes today, so if you had a question but I didn't go over it in here, please check out the videos from the other classes. Send me messages in Canvas. I also have office hours today for half an hour after school if you want to stay for extra help.